Ever felt like we're living in the future? Our phones are more powerful than the computers that sent humans to the moon. But what if I told you we're on the verge of a leap so massive it makes your smartphone look like an ancient abacus? This isn't science fiction. This is the dawn of the quantum age, and it's about to change everything. Imagine a computer that doesn't just think in ones and zeros, but in a kaleidoscope of possibilities all at once. That's the mind-bending reality of quantum computing. Your laptop, for all its power, works like a series of light switches. Each switch is either on or off, a 1 or a 0. This is Avit. It's a simple, reliable system that has powered our digital world for decades. But it has limits. For some of the universe's biggest, hairiest problems, even the world's most powerful supercomputers would take billions of years to find an answer. They get stuck trying one combination at a time, like a safecracker trying every single number in order. Quantum computers play by a whole new set of rules. The weird and wonderful rules of quantum mechanics. Instead of bits, they use qubits. Now, a qubit is where things get interesting. Thanks to a principle called superposition, a qubit can be a 0, a 1, or both at the same time. It exists in a fuzzy, probabilistic state until you measure it. Think of it like spinning a coin. While it's in the air, it's not heads or tails, it's a bit of both. It's only when it lands that it picks a side, and it gets even wilder. Qubits can be linked together through a phenomena Einstein famously called spooky action at a distance. It's officially known as entanglement. When two qubits are entangled, their fates are intertwined, no matter how far apart they are. If you measure one, you instantly know the state of the other. It's like having two of those spinning coins, and the moment one lands on heads, you know the other, even if it's on the other side of the galaxy, has landed on tails. So what does this mean in practice? By harnessing superposition and entanglement, a quantum computer can explore a vast number of possibilities simultaneously. While a classical computer checks each path one by one, a quantum computer explores every path at once. For certain problems, this isn't just a small speed boost. It's an exponential explosion in processing power. A computer with just 300 entangled qubits could hold more possible states than there are atoms in the entire observable universe. That's the kind of power we're talking about. So, what problems will this incredible power solve? Let's start with medicine and materials science. Discovering a new drug, or creating a revolutionary new material, is incredibly complex. It involves simulating how molecules behave, a task that quickly overwhelms even our best supercomputers. But molecules themselves are quantum systems. A quantum computer speaks their language. It can simulate them with perfect accuracy. This means we could design life-saving drugs tailored to an individual's DNA, create new catalysts to pull carbon out of the atmosphere, or develop revolutionary battery materials that could power entire cities. We could unlock a new era of personalized medicine and sustainable technology. Then there's the world of finance and optimization. Think about the ridiculously complex systems that run our global economy, logistics, and supply chains. Finding the most efficient route for a fleet of thousands of delivery trucks is a classic optimization problem that gets exponentially harder with each new destination. A quantum computer could solve these puzzles in a heartbeat, saving billions in fuel costs, reducing emissions, and making our entire infrastructure smarter and more efficient. It could revolutionize weather forecasting, financial modeling, and complex risk analysis, giving us the ability to predict and prepare for everything from market crashes to hurricanes with unprecedented accuracy. Artificial intelligence is another field set to be transformed. Quantum machine learning could accelerate the training of AI models, allowing them to find patterns in vast, complex datasets that are currently invisible. This could lead to breakthroughs in everything from medical diagnostics to creating truly intelligent AI assistants. The synergy between quantum computing and AI could be one of the most powerful technological forces in human history. But with great power comes great responsibility and some serious challenges. The very thing that makes quantum computers so powerful, their ability to break complex problems, also makes them a threat. Most of the encryption that protects our data today, from your bank account to government secrets, is based on the difficulty of factoring large numbers. For a classical computer, this is an almost impossible task. For a large-scale quantum computer, it's trivial. This means that once a powerful, fault-tolerant quantum computer is built, it could potentially shatter the cryptographic foundations of our digital world. This is the so-called quantum apocalypse. Everything we consider secure online could become vulnerable overnight. The race is now on to develop new forms of quantum cryptography, new mathematical puzzles that are hard for both classical and quantum computers to solve. We're in a high-stakes race between building the lock and building the key. And building these machines is no easy feat. Qubits are incredibly fragile. The slightest vibration, temperature change, or stray magnetic field can cause them to lose their quantum state. In a process called, it's like trying to keep that coin spinning in the air for as long as possible. To combat this, today's quantum computers are massive, delicate contraptions kept in near absolute zero temperatures, shielded from the outside world in what look like futuristic golden chandelier. We're still in the very early days, the vacuum tube era of quantum computing. The machines are noisy, error-prone, and can only handle a small number of qubits for a short time. But progress is happening at an astonishing rate. Tech giants like Google, IBM, and Microsoft, along with a swarm of ambitious startups and university labs around the world, are pouring billions into this research. They are constantly pushing the boundaries, increasing qubit counts, improving stability, and developing new algorithms. Every month seems to bring a new breakthrough that was considered impossible just a few years ago. So, are we ready for this future? In many ways, no. The societal, ethical, and economic implications are vast, and we've only just begun to grapple with them. Who will control this technology? How do we ensure its benefits are shared by all of humanity, not just a select few? How do we manage the transition to a post-quantum world without causing chaos? These are not questions for tomorrow. They're questions for today. The quantum revolution isn't a distant dream. The first waves are already beginning to lap at our shores. It won't happen overnight, but its impact will be profound, touching every aspect of our lives. It promises to solve some of humanity's greatest challenges and unlock a new frontier of discovery. It's a future of unimaginable complexity and unprecedented opportunity. A future that no one is truly ready for, but one that is coming nonetheless. We are standing at the precipice of a new computational era, and the world will never be the same. Thanks so much for watching. If this peek into the quantum realm blew your mind, be sure to hit that like button and subscribe for more deep dives into the future of technology. What part of the quantum revolution are you most excited or worried about? Let me know in the comments below. See you next time.